Chapter 5 Timing Hazards deals with 3 hazards: setup, hold, and with time. The chapter's objectives are to identify and correct a variety of timing violations and to display multiple hazards. The circuit we will use is a basic DLAT setup. We label each of the node's inputs and outputs and set the stimulus generator to respect a sequence of digital values. In order to see the timing hazards, we will set the circuit simulation to run in worst case scenario mode. We run the simulation and a warnings message box will appear. We select yes to view the messages. In this example, we want to view the first 3 messages and plot them. We do this by highlighting each message and clicking plot. Once all are selected, click close and select the first tab. This is the setup timing hazard. It occurs at 20 nanoseconds because it is when the system first determined that the time between a data change from the D1 signal at 4 nanoseconds and a clock pulse transition of D0 at 20 nanoseconds, and that was below the minimum of 20 nanoseconds for the setup timing. The next plot shows the hold timing hazard. This violation occurred at 24 nanoseconds because this is when the system first determined that the data input of D1 at 24 nanoseconds changed too quickly after the clock signal D0 at 20 nanoseconds went to an active high signal. The last timing hazard is the width hazard. This type of hazard occurs at 40 nanoseconds because that is when the system first determined that the width of the clock signal D0 was too small to meet the requirements. This concludes our discussion on Chapter 5 dealing with setup, hold, and width timing hazards.